good morning or good afternoon, depending on where you're calling in from. I just want to welcome everyone to the first fall webinar of Connecting the Dots. Thanks so much for all of those who have attended today. Just wanted to let everyone know that you are all on mute just for the respect of the presenter so we don't have any background noise. Just a couple of housekeeping items before we begin. For those of you who are interested in or need professional development credits, there will be certificates provided at the conclusion of the webinar when we receive a roster of the names who attended. We are also, as you have heard, recording the webinar today, and it will be available at our website following the recording at connectingthegovdots.com. I'll send out an email as well to all those in attendance with all the information. If you have questions throughout the presentation, we ask that you type those into the lower left-hand corner of your screen where it says Q&A. I will receive all of those and help the presenters moderate. So without any further ado, I'd like to introduce our speakers today, who are Jay Thompson and Cliff Selkinghaus of South Carolina Department of Transportation, and they're going to be discussing with us their unique experiences while reconstructing about 12 miles along Interstate 85. So with that, Jay and Cliff, go ahead and take it away.
All right, good afternoon. This is Jay. I'm going to get things started. We're going to talk mostly about the I-85 reconstruction project, and we're going to, if we have time, also touch on a project on I-385 that utilized a similar approach. So the main focus today was I-85 from 58 to 68, and this section was built in two different projects. They were completed in around 1958, 1962, and they were initially built with kind of minimal structure. Lift of intermediate, a lift of surface, over some graded aggregate base that had a bituminous treatment over that to help protect it during construction. And then that was built up incrementally over time with overlays to get us where we are today. Now, part of the issues that we had there when we built up with the overlays was we didn't always fix all the issues that were there. Sometimes we did, and sometimes we just kept building up. So over time, those issues tend to kind of stack up on us. By the time we got around to 2014, it was time to do something with the project. Now, we had been going through a period of time where we didn't have a lot of funding, and this project really probably should have had something done to it preferably earlier, so it wasn't in particularly good shape. The scope of the project was basically removing and replacing the upper 5 or so inches of surface, and that was what had been done on the two projects on either end of this previously. So it came time, we milled off the surface and put traffic on there, and it went to pieces on us. There were some mix issues that just fell apart, and it became very obvious that what we had done in the past was really no longer appropriate. Those issues had degraded to the point of putting traffic on a milled surface was not happening. We were also having a lot of potholing issues, and just became obvious that we really needed to take a closer look at this thing and come up with a new way of fixing it. So when we started through the investigation, coring to figure out exactly what was going on, right off the bat we saw that pretty much all the cores had an issue in the upper 5 inches. There were some mixed quality issues, there was some debonding issues, and generally some top-down cracking that was occurring at least most everywhere. In the places where the distresses were limited to the upper 5 inches, what you saw on the surface was relatively low severity. usually a top-down cracking in the wheel paths, and occasionally there were some places with no cracking, but most everywhere had at least some longitudinal cracking in the wheel paths. About half of the cores we looked at, which represented about half of the cracking that we saw, had distresses that went down to at least 8 inches. The surface conditions here were relatively poor. There was a very well-defined longitudinal wheel path cracking, and these areas were really prone to potholing. As you can see, these upper 2 layers were delaminated, and especially during the wintertime, we were having these areas come out and pothole along the joints and within the wheel paths. Further, a little less than half of all of the cores that we took showed distresses that extended below 8 inches, and some were deteriorated very significantly, having cracking throughout the entire depth. The average depth of asphalt out there is about 19 inches, which you would think would have been enough, but the problem was that it wasn't built with 19 inches initially. In these areas where we had full depth distresses, it was pretty obvious on the surface. Usually we would have 2 wheel path cracks that were running together, and it got to be very typical that you could see that type of cracking on the surface and know what you were going to have underneath. So how were we going to fix it? Well, first we were limited by some of the stuff that we could do. Obviously the structure out there was deficient and we needed more, but we couldn't build up because we were tied down by a barrier wall in the center. So we have a deterioration in the upper 5 inches everywhere. We had 50% or more of the critical lane had at least 8 inches of cracking. In a lot of cases it went deeper than that. And then our traffic control limited us. Initially when we started discussing this project, they said, you're only going to have nighttime lane closures. That presents a problem. Eventually we got that extended out to be able to have some extended weekend closures. But still we had to come up with a way that basically we could take out, fix the problem in a night and come back. And we said, how are we going to do that in a way that we minimize our construction joints, maximize our production moving down the road? So this was the plan we came up with. We said, all right, we're going to mill out 10 inches in the right lane and replace that with a little bit of additional structure. And we're going to go 5 inches in the left and the middle lanes. Again, replace that and add a little additional structure. We got to thinking about how much asphalt could we put back in one lift. And we all know that we've seen asphalt put in widening situations and tapers where it's deeper than our recommended lift thicknesses. But how do we do that on an interstate in a way that we can feel confident about it? So we started thinking about ways that we could tweak the mixture in order to help us with our compaction, help us with our temperature during hauling, and be able to increase our production. So what we finally settled on was going with 400-pound lifts, 2 400-pound lifts, which was going to facilitate the need to place a leveling course across it to tie it down to the adjacent lane. And then we would come in with 2 relatively conventional lifts on these other lanes and then cap everything off with a little additional structure. And this is what kind of precipitated our new mix that we came up with called Intermediate B Special, which Cliff is going to be telling you a little bit more about the details of. So we thought that we could probably get away with doing more than 400-pound lifts, but we were concerned of letting a project that way. The last thing we wanted to do was put out a contract and then get out there and find out that we couldn't do it. So we let the contract as was shown on the last typical section. But after the award and through some discussions with the contractor, they decided to propose to alter that, and the lift thicknesses of these two were increased to 450 pounds, which eliminated this step of E, and then these two lifts also went to 1. We said, okay, we think you can do that, and luckily by plan, our specification had a requirement of a test strip in there. So we had full depth shoulders beside there. So we required them to go into the shoulder and mill out and prove to us that they could get compaction within these lifts as proposed. So we did that. Things turned out to look good. We moved on forward to production. So this is kind of how it turned out structurally. We had a couple of previous FWD measurements out there, and the original structure was obviously deficient before. This is what it looked like after the initial mill 10 and put back 9. We came in with structural number of 8.31. We were already exceeding our design at that point, and we still had surface A and OGSC to place. So we felt pretty good about that. So in the end, the final thickness will be approximately 11.8 inches. The idea here was, with given the support of the remaining asphalt and base course beneath that, the hope is that this 11.8 inches will be sufficient to provide a perpetual section in that critical lane moving forward. So how did it ride? Well, when the first lifts of Intermediate B Special went in, as to be expected, there was a little bumpiness there, especially at the joints, but it wasn't terrible. After the surface A was placed, it was well within our specifications. So we were very satisfied with the ride. Now Cliff's going to talk to you a little bit about mix design.
Thank you, Jay. A little bit about the mix design. We looked at the what we call the Intermediate B Special. It's what we came up with, and we had some things that we were looking for. Obviously, we wanted to place a mix that would obviously hold up under traffic. Of course, had enough stiffness and serve as a riding course, and it was fine enough in gradation to seal out the water. That was the main reason for eliminating the surface type E, which is the surface E, as Jay mentioned, that we eliminated by using the special mix, was a 4.75 millimeter mix. So by doing that, we needed to use something a little bit finer in gradation as compared to what we used to use previously with any intermediate mixes, especially using super pave type of mixes that we used in the past. And of course, it needed to be open to construction throughout the construction season, and we're not sure, again, how fast we were going to be able to place this mix and when that final surface was going to be put on top. That surface A surface that was mentioned is a 9.5 millimeter surface that we typically place on top of the intermediate. And then on the final top would be the open graded friction course, which is a 12.5 millimeter placed at 110 pounds per square yard. So we had to have something that was fine enough, again, to be sealed out, that we didn't need to have that seal course placed. So again, we are obviously looking for a mix that was easier to compact and obtain as much density as possible. Of course, we're putting down 450 and 495 pounds per square yard lifts, so we were really concerned about how to do that. And of course, as Jay mentioned, a lot of this was dealing with nighttime closures. We did have the weekend closures, which was very, very helpful for getting more and more production done in a lot. But the production, of course, return to heavy traffic was a huge concern. Being I-85 is our most trafficked road in the state of South Carolina, we needed something that was going to be very, very robust and hold up to traffic. Basically within 30 minutes to an hour of our paving crew picking up traffic control and turn it again to rush hour type traffic situations. So again, what mix should we use? Well, we were looking at, again, the strength and durability. So again, looking for a finer mix that would seal out the water flow if exposed for several months. Hopefully not years, but we were really unsure, how long it was going to take, considering we have 12 miles of rehab to do. We're looking at a several-year project, likely. So we looked at our older 12.5 millimeter super pave surface, typical what we used to use starting in about 1995 is our old 12.5 millimeter. We currently use that as our typical intermediate B mix now. So again, it's 12.5 millimeter. The difference is our gyration levels over the years have kind of like all the rest of the states have kind of reduced down to a levels. That is a 75 gyration mix. So back in years and years ago, that was 125, 109, 106. Remember those days of really high gyrations with low asphalt content. So again, we're down at 75 gyrations. We used this PG64 -22 versus the 7622. Again, this is not our final riding surface. We're going to put a surface A 9.5 and open graded on top. Those will receive the PG7622 as the final riding surfaces. We also wanted to be green, use a wrap as much as possible, so we allowed up to 30% age binder percentage based on the optimum asphalt of the design. All right, and it's also noted that our intermediate B mix that we typically place has a maximum depth of 2 inches based on the nominal maximum aggregate size of ½ inch. That's our typical spec is 2-inch max compacted. So we're going way, way beyond that. And we look at our current B mix, of course, and how are we going to make it more durable and easier to compact. So we looked at the lower design air voids. We need to look at that. We typically target around the 4% number. So we wanted to make a significant increase in asphalt content, so we started looking at targeting about 2.75% air voids. We also lowered gyrations again from our old design from 100 to 75 gyrations, again increasing binder content. And we also really wanted to, again, use wrap to increase stiffness. So we're putting on 85, we're not putting a 7622 asphalt in it, so we needed that extra rutting resistance that we expected to get from our wrap. And considering what we needed to try to do everything possible to obtain as much density as possible to help or aid in our compaction process, we started toying with the idea of using more mixed asphalt. And with that, we wanted to look at, our concern was, hey, we've got to turn this deep section, roughly 9 inches of hot or potentially warm asphalt to I-85 traffic conditions. So how would we do that? Of course, we looked at warm mix technology. How do we get even lower on our temperature as far as return to temperature or return to traffic temperature? So it was pretty clear that we needed to use a chemical process just to get as low as possible, get it down very low. So back to how we checking compaction and how confident are we going to be in the contractor's efforts. As Jay's mentioned before, we did a test section. We had some concerns about cutting cores. We typically cut cores on anything on the interstate because we're concerned about getting as much density as possible. So we had some concerns about cutting those cores and leaving those really deep holes, 9 or 10-inch holes in the road. And you know how difficult that is to actually get those holes filled in and compacted properly. We didn't want to leave, half dozen holes in the road that weren't compacted properly, and then make a mistake of covering that up later on down the road with surface and intermediate that potentially could pothole. So had concerns there. Also had concern, of course, with the contractor able to stop early enough so the QC could cool the pavement down to cut cores. It takes a long time if it's in a confined situation like on the 85 with the deep sections, allowing that pavement to cool down enough so we can, no matter how much water you put on it or how much ice, so we can actually obtain cores without damaging the cores. And of course, fill the holes up prior to opening to morning traffic was also a concern, as I mentioned earlier. Had concerns with the vertical edges, the joints, getting enough compaction. Here we are cutting out a deep section and not really having a lot of chances to stagger those joints. If it was a new construction project and we're starting from the bottom up, we typically like to space those joints out, 6 inches to a foot if possible, so we get the stair-step effect and we won't have a potential for a deep crack to occur. So had concerns there. So of course we went to a test section. And we decided, of course, on the test section, as Jay mentioned, we're looking at mainly on the shoulder, so we're not really worried too much about filling holes as much on the shoulder as we would have been on a main line. So We took full depth cores in the test section and also took gauge shots to establish the offset. So our idea was once we felt really comfortable with the density that the contractor was getting on their test section, that we would feel comfortable with taking gauge shots for the final acceptance of that mixture. So we took cores and gauge shots in the mainline section, of course, as we normally do. But we also took cores and gauge shots within about 6 to 12 inches of the vertical joint. So we had a real concern about that crack reappearing in that deep section in those joints. So we sliced the cores in multiple layers, not just to check the full core. We did that as well, doing the 8 or 9 inch, 10 inch cores. But we cut them in, say, 2 inch layers, and we checked the density from each layer and made sure we felt comfortable about the compaction from bottom up. Use different gauges as well. Contractor was kind of anticipating that we were going to allow them to start northbound and southbound operations. So we had to be concerned with that, and since we were out there doing the test strip, it's a perfect time to really over-test. Let's get as many gauges out there. If we have a nuclear gauge or a non-nuclear or electronic gauge go down for some reason, we wouldn't necessarily have to set up a new test section, which we didn't want to go and have to do. So we did that. We also required an additional QC plan. We wanted the contractor to come up with an approved plan ahead of paving, of course, to address some concerns. And these are pretty typical concerns, but we wanted to kind of have something in writing. But we also wanted to be able to have something that the contractor was able to amend if needed, based on the traffic conditions, and try to obviously maximize production. Lane closure restrictions, how are we going to adjust that? That changes every day based on the distance from the plant and which lane you're in, obviously. Milling operations I mentioned earlier, we would love to be able to stagger the first and second cut with the milling operations. We looked at doing that later on down the road once we did the deep section. If we felt like we weren't getting the compaction in that longitudinal joint, we felt like we could ask the contractor to cut off an inch or two, up to 6 inches off of the new pavement if needed, if we felt like we didn't get good compaction in the joints. Of course, anytime you got a deep hole in the pavement and in any road, very important that if we have a breakdown of a plant, obviously those are going to happen, that the contractor has an available backup asphalt plant. So the contractor was able to procure or have at least one extra plant just in case they needed to, and also obviously to increase production, especially when we're talking about later on going to northbound and southbound on the same night. Cleanup, of course, sweeping operations, you got a very deep hole. It's true with any full depth patching operation. It's very difficult to clean the holes out properly before placing the new mix. We wanted to make sure that we got those operations as clean as possible. Most of the deep operations were replacing 9 inches in one night. We had dual lane closures, so we were able to run the MTV into the other lane, and basically keep off of the tack, which is really key. We wanted to make sure that we applied the tack, keep the trucks and the MTV equipment off that as much as possible. And based on the tack, we were obviously paving at night. So anytime we're paving at night, we have issues with emulsions taking a little longer to break, obviously, because we don't have the sunlight and the heat outside. And we were working ourselves into the wintertime. This was, I think our test section was placed in 31-degree weather, so not extremely great as far as a good time to do a test section. But we also felt like, that was a great time to, go all in on it and see, what would happen. So we did that, and we used PG 6422 as our tack, so we didn't have to worry about braking. We just had to worry about a little bit about safety concerns. So there was some training involved there to make sure no one got burned using the 6422. Of course, paving, MTV was required, and trucking plan, we needed a trucking plan to make sure that we maximize production as much as possible, especially when you're dealing with milling operations, cutting out as much as we did in one night. We had to use a lot of trucks. Copy of our specification. It was just a special provision that was used in our contracts. This is pretty much just to kind of reiterate what we just talked about. Our qualified products list is our QPL for warm mix technologies. We required a chemical process, again, to try to maximize the reduction in temperature. That was what we were after. So we were going as low as possible. Again, target voids. We tried to target around the 2 3/4% mark, and we did that. And of course, we used nuclear or non-nuclear gauge, and it spells out some of the requirements that were in our testing plan. Here's some of the results on compaction. We're again concerned. I mentioned earlier, we're concerned about some of the joints and the, of course, mainline operations and the results. On the first sheet to the left, as you see the joint compaction average was 93.3%. Typically, our specification on our bottom spec limit is 92.2 to 96% is our upper spec limit for compaction. And that's in our mainline application. So we got actually 93.3 average density close to that joint. So that's, again, that was very, very good news for us. And our mainline compaction averaged 96.2. So we were real happy with that. We were really concerned about being over-compacted. If we were concerned about that, we could obviously cut asphalt binder content down and reduce the number of number of passes with the rollers. So again, the other section on the right is just basically showing where we saw cut the cores into 4 sections, roughly 2 inches or so at each layer, and you see the consistency and the compactive effort that we obtained. Again, gauge shots, Sloan Construction, didn't mention them. They were the actual contractor that was awarded this job. They've been really, really good to work with on this particular job. Gauges, as I mentioned earlier, we took a lot of gauge shots. This is just one example of one where we used a PQI gauge, which is an electronic gauge instead of a nuclear, but we did both. The contractor eventually, I think, went to all non-nuclear gauges for this project just for speed of taking gauge shots. But we were real happy with it. Going back and forth, we allowed the contractor to choose which gauge they would like to use. This time I'm going to switch it back over to Jay. Let him talk about the next project, 385. I think we got a few minutes so we can talk about that. It's very similar to what we did on 85.
So I-385 was a project that came along very shortly after what we did on I-85. And this is a shot of the nighttime when we were placing the intermediate B special. You can see the first lift was already down, and we had quite an audience out there watching that night. So this is where we started. It was originally a 2-lane interstate that was widened to the outside, which we don't do a lot of, but it was widened to the outside and then overlaid at some point in the past. This is what it looked like. That outside lane that was widened to, on the southbound direction for about 4 miles, was in very poor condition. In the middle lane, there was some isolated fatigue cracking that needed some patching. And then we had this longitudinal wheel path crack in both wheel paths. It was pretty much consistent throughout the project. On the northbound side, this critical lane looked more like the middle and left lane. So what really made this project ideal for the intermediate B special was this 4-mile section that we needed to replace. This is what it looked like. The overlay that had been placed previously was delaminated pretty much everywhere. There was top-down cracking that in a lot of cases terminated at that delamination, in some cases terminated just slightly short of that. There were some zones of some poor mixes in there, but over in the 4-mile section of the critical lane, we had some very significant deterioration going on. A lot of stripping in the base. There was some what appeared to be compaction issues initially, cracking throughout, and in some cases we could literally dig out the remainder of the base with a spoon. So we were faced with another similar situation. How do we take this out and put it back, keeping it in service? This road leads right into downtown Greenville, so a lot of car traffic, not an enormous amount of truck traffic, but obviously a lot of traffic during rush hour for us. So this was the plan on the southbound direction. We ended up coming in and cutting out approximately 14.5 inches of structure, replacing 13.5 inches, and then overlaying that with a surface and OGFC. The remainder of the sections, we basically replaced that overlay that had been put on there before at 4 or 5 inches. Before I switch off of that, this was set up to be done in 3 495-pound lifts. This was set up to be one 350-pound lift plus 200 and 125 for the OGFC. So the intermediate B special was utilized for the majority of this structure and all of this mill and fill, and then we capped everything off with our typical surface A that we use on our interstates. Now, one of the things that both of these operations allowed us to do was place that more or less year-round. So it allowed the schedule of this project to proceed very aggressively. So what did it look like? Well, this is a core of the first lift that went in. Now, initially, contractor, which was the same one that got the other job, so they were familiar with material, they made a request to put in the first lift at 7 inches thick. We were a little concerned about that, and we said, well, let's don't go quite that deep, but this is a test strip, and we'll let you push that up to about 5.5 inches, and let's see how that goes. So our first lift on subgrade went in at 5.5 inches, and then the remaining lifts were thinner as you went up to fill in the 13.5 that was put in a night. We went back and got some FWD data on it at about a week out, and that number was testing out at about a 4.8, which was just slightly below what our assumed structural value should have been for it, but extremely close. And it should also be noted that the asphalt only being a week old, if we go back and test it, there's a definite chance that that number is going to be a little bit older, just as the temperature is allowed to settle down in that material, being that it was put in so thick. Long story short, we were happy with it. It looks good. Another thing that I was able to see on this FWD testing is these tests are pretty consistent. We got a very good correlation here. If I saw this line being flatter, it would have told me that there was a lot more variation in the structural response or the stiffness of material that was there. So we're very pleased with how that ended up. That project is still under construction, and we will be getting some more data on it as the surface is placed. That brings us to the end. So
the conference has been unmuted.
So thanks so much, Jay and Cliff. I have unmuted everyone. I hear a little bit of an echo now. I don't know if somebody has it on speaker, but I can mute it again, and I'll just give you a chance to chat in some of your questions. We already do have a couple of questions, so I'm going to mute it again just to get rid of the echo.
The conference has been muted.
And Jay and Cliff, if you can still hear me, I'll go ahead and ask the first question that I see. It says, with all the field experience and success you've had with this technology, where else do you plan to use it, or can you see it being used?
Most certainly. So we see a couple of different ways to use this material. One, we're actually going to be placing some on the NCAT test track coming up to get a further understanding of what's going on with it. We're facing a situation with our primary routes where we've got a large percentage of our primary routes that need reconstruction. So we're really trying to see how we can maximize the use of this to potentially reconstruct some of those primary routes, and that's something that we're hoping to get from the NCAT study especially. And then lastly is full depth patching. We've already started utilizing this in some full-depth patches. We think that this may be the future for us to be able to get ourselves down to only using a couple of lifts in full-depth patching, increase the production there. We have also successfully used this on a temporary alignment on a design build project where the shoulder was strengthened to handle the temporary alignment. So we're seeing quite a few uses for it, actually.
Great. Another question asks, what are some of the lowest temperatures you've been able to work with this new technology?
So what we've seen so far, the first test trip that went in, it was about 31 degrees that night at the conclusion of the test trip when they were finishing up rolling. So we've gotten down to right around freezing or possibly just below freezing with it so far. And it worked out great.
Great. We have another question that's come in asking, what was the tack application rate and what temperature did you open the lane to traffic at? And then did you utilize an anti-strip additive with all mixes since you detected stripping in the course? So we take them one by one.
Okay. The tack, of course, is 6422 was utilized, and I pulled a report just yesterday on it, looked it up. It averaged about 0.06. Again, 0.06 gallons per square yard was the average rate, which we applied that at 6422. And of course, we made sure we applied an extra dose of that on the vertical joints after we milled it. Obviously, we wanted to make sure we coated those. So we really paid a lot of attention to the quality of having to apply those to that vertical joint being so high. Up to the 9 or 10 inches deep on the 85, and of course even deeper on 385. So there was a lot of attention needed to apply that. The other question you had was dealing with, what was the other question, Amy?
Yeah, the next one was, so you just answered the question about the tack, the temperature that you opened the lane to traffic at, and then if you utilized an anti-strip additive with all mixes since you detected stripping in some of the course.
Right. Well, our typical anti-strip agent in that intermediate B is hydrated lime was being used in this particular application. But with the chemical warm mix additive, it did have a bonus as well as having an liquid anti-strip as well attached to that warm mix additive. So we kind of had a double dose of anti-strip.
Wonderful. Just out of curiosity, with the weather that's come through South Carolina, how are the roads? What's the status of the roads, or can you give the group any information on how things are going?
Well, I'm not aware right now of any particular issues that we're having. I think we were very fortunate and were able to not experience some of the stuff that's going on in Georgia and Florida.
Wonderful. That's good to hear. If you have any additional questions, we'll give everyone the opportunity now. You can either chat your question in the bottom left-hand side of your screen, or you can click the arrow, the down arrow next to your name, and raise your hand, and I can unmute the call and you can ask it if you feel more comfortable that way.
Hey, Amy, this is Jay. I'd like to make one comment about a previous question. So one of the other questions was what temperature did we open it to traffic, and I cannot say the exact temperature that we opened, but I can say that it was pretty regular occurrence that there was not very much time between the completion of compaction and opening to traffic, and a fairly significant amount of traffic. Now I will say that when you're watching this material go in place, it's pretty tender, and the fact that it's confined in a hole is really a necessary part of the success. So it would not work out the same way, I don't believe, if it was not in a hole. But I remember on the 385 project, we were watching the test strip going in, and it was tender. We were a little concerned. I went back that morning. Everybody kept a very close eye on it. Traffic was released onto that within 2 hours of the time of compaction, I would say, if not less than that. less than an hour probably. We did not have any issues with it. Now, obviously, this is not stop-and-go traffic. This is traffic pulling straight through. If this was an intersection, maybe a little differently. But we did not have any issues that we know of related to opening it to traffic, and we did so in less than an hour a lot of times.
Fantastic. Any more questions from the audience or anything else to add, Cliff and Jay, before we close? Okay, we do have another question. It's asking, why not use a 25 millimeter super pave with 3% voids in the lower lift?
I think our concern with using a course graded mix was it being open to traffic, and this was likely going to be open for over a winter after the intermediate B was placed. We were concerned, again, we were trying to put something fine graded down that would service as a surface mix for the over the winter months, and we didn't have to necessarily use the surface E or 4.75 millimeter to use as a seal course to protect that 25 millimeter.
Great.
And another part that I would add on to that is we had to get this project together very quickly. We had a contract that was in issue. The road was literally falling apart, and we had to do our investigation, come up with how we were going to fix it, work with pre-construction to develop the staging plans, and all of that, and let it, and all of that transpired in less than 3 months. So we actually looked at quite a few different ways to take this mix, but we had to pick something that was going to require the fewest changes from what we already had specifications for. So this was our, how can we make this as simple as possible and get it done approach.
Do we have any other questions from the audience? I think we've answered everything. I just want to thank Cliff and Jay for their time, and the audience for all those of you who have attended. Like I said at the beginning, we will be offering certificates for professional development for those who have attended. So I'll be following up with an email that has a professional development certificate for each of you individually, as well as a link to the recording where you can watch this again, or you could share with others in your agency. If you need contact information for the presenters, we can look into providing that as well. But thank you again so much for joining us today. We hope this was worth your time, and we look forward to hosting you again in the future.
Thank you, Amy.
Thank you.
Thanks.